when you're asked to demonstrate that triangles are congruent, the best, and this is your diagram, you first look at it and decide which sides are congruent, which angles are congruent, and then you decide if you're going to go for ASA or SSA, SSS, or whatever it might be. So I'm first of all, I'm saying it's a parallelogram. So that's the same length as that, and that's the same length as that. And obviously this is the same length as itself. So we have SSS in this particular triangle, don't we? So what we'll do is your strategy will be you're going to write down, you want to show that triangles ABC and ACD are congruent. So let's do triangle ABC and do triangle ACD. And underneath that, I'm now going to write down the three lengths of the lines to show that they're equal to each other. So I'm going to start off by saying that in triangle ABC, which is this one here, I know that the length AB is equal to the length DC. So the length AB is equal to the length DC. And the reason which you put over here is because they're opposite angles, opposite lines, opposite sides in a parallelogram. PAR, parallelogram. Okay, the other two sides are the same. AD is the same length as BC. So AD is equal to BC. And again, opposite sides in a parallelogram. It's the same reason. And then the line AC is equal to the line AC. It's a shared line. Okay, so there we have, in this triangle, we've got these three things are the same as these three. The three lengths are the same. Therefore, the triangles ABC is congruent to the triangle ACD. Okay, by SSS. Okay, so that's how you do it. Let's have a look at one more example. Now, the straight lines AB and CD are parallel, and they're equal as well, so it's parallel. So we'll be able to look at corresponding and alternate sort of stuff maybe. And also they're the same length, so we have the sides of the same length. We have to prove that these triangles AEB and DEC, that these two triangles here are congruent. Okay, so let's get going. We're going to put AEB and DEC. And I write down the stuff underneath them that are going to be equal to each other. Okay, so we then build up. So what am I looking for? Well, I do know that this triangle here, this angle, is the same as this because they're vertically opposite. And I do know as well that this angle here, we have corresponding, we have alternate angles, should I say. So this angle here, I'll put a little maybe circle like that. That is the same as this. All right, and then that means that the third one must be the same as well because it's the third angle in a triangle. Okay, so what do we have so far? We have a angle, side angle, ASA. We haven't used the one in the middle actually. We've used angle, side, angle. Angle, side, angle. Okay, so let's do the angle first. So I'm going to look at this one here, EAB. So the angle EAB is equal to the angle EAB is equal to the angle CDE. You could have written down, beg your pardon, you could also have written down, instead of writing down CDE, you could have written down EDC, it's the same angle. So let's just check that again. EAB is equal to EDC or CDE. So it's the same. And the reason is because they are alternate angles. So they're an alternate. And then the second side, we know then that the length AB is equal to the length CD. Okay, that's given. Okay, that's the reason for that. And then the third angle we're looking at is this third angle here, this ABE angle. Okay, so now we're going to go that the angle ABE, and it's quite easy to get mixed up with your angle names here, so be careful. So ABE, that angle there, is equal to the angle Angle ECD. And that is also because they're alternate. So we've now shown that our triangles are congruent. So the two triangles, we've got triangle AEB and triangle DEC. DEC are congruent by, and it was by ASA, is by the reason, by ASA. Okay, hope that helped.